The third connection is the series connection. The R parameters of the first two-port network is R prime, and the R parameters of the second two-port network is R double prime. Connecting their input and output ports in series respectively, then we get a new composite two-port network. In this connection, I1 equals I1 prime and equals I1 double prime, and I2 equals I2 prime and equals I2 double prime. The port voltage U1 equals U1 prime plus U1 double prime, and U2 equals U2 prime plus U2 double prime. Substituting their R parameters and applying the relationships of their port currents and the voltages, we get it equals R1 prime plus R prime plus R double prime times the port current. The R parameters of the new composite two-port network is R, which is equal to R prime plus R double prime. This is a relationship of the R parameters of the two-port networks in the series connection. Similarly, it can be generalized to the series connection of multiple two-port networks. Similar to the parallel connection, when two-port networks connect in series, their port conditions are possibly broken. Let's look at this example. This is a first two-port network, and this is a second two-port network. Before the series connection, they are connected to the external current circuits by their own ports. According to the generalized KCL, they satisfy the port condition. After the series connection, assume two current sources are connected to these two ports now. The current through this branch should be 2 ampere, and the current flowing in is 1 ampere. The current flowing out here is 2 amperes. The current flowing in is 1 ampere. In other words, the port conditions of the composite two-port network is satisfied. What about the original two-port networks? What's the current through this branch? This is a series connection of 1 ohm resistor and 1 ohm resistor, and this is also a series connection of two 1 ohm resistors. So the currents through these two branches are same. They equal 2 ampere plus 1 ampere over 2 ohms, that is 1.5 ampere. The current here is 1.5 ohm ampere too. Of course, the current flowing in is 1.5 ampere, and the current flowing out is 1.5 ampere. Now we find for the original two-port networks, their port conditions are broken. The current flowing in isn't equal to the current flowing out at this port, so does this port. The port conditions are broken. For this circuit, you can deduce by yourself after class that the R parameters of the composite two-port network isn't equal to the sum of the R parameters of two-port networks in a series connection. So, in what case will the series connection of two ports not break their port conditions? Similar to the parallel connection, if both two-port networks have the common terminals respectively, then connecting their common terminals in series will not break their port conditions. It's called the standard series connection. The detailed derivation process is omitted here.